first project of limits in differential calculus. So the first problem we have is limit when x is approaching to 3, parenthesis, square root of 2x plus 3, close parenthesis, minus 3, divided all by x minus 3, parenthesis. So we have the graph. In the graph we can infer the limit, but it's not as clear as we want, so we need to do the problem. So first we need to do is put the equation limit when x is approaching to 3, parenthesis, a huge parenthesis, because come on, it's a huge problem, so we need to do this plus 3 minus 3 parenthesis here and divided by x minus 3. We can't substitute the values because we could have a 0 divided by 0, so this is another answer. This is a trash again. So we need to have numbers that can be like close to 3, so we could put 2.9. X is equal to 2.9, so we can like infer, so 2 plus 2.9 plus 3, close parenthesis, minus 3, divided by 2.9 minus 3. This is result of all of 0.3352. Why? With the other hand, we need to have number higher than 3, so we take the 3.1. So the same procedure, 3.1 minus 3, 2 divided by 3.1 plus 3, close, minus 3, square root, parenthesis. The result here is 0.33 is 15. So if we add and then divide it by 2, the result that we have is 0.33 as simplified, or it could be 1/3. So this is the result, and that's all. So here we are again in our second exercise about limits in differential calculus. So the second exercise is limit when x is approaching to 4, and the problem is x square minus 16 divided by x minus 4. So here in the graph we can get already the result. So if we put attention, we could have that this is 1, 2, 3, 4. That is our number, and when x is approaching 2, we could have that here's the point. So here's 6 and 7 and 8 and a 9. So we could have an 8, 8, 4. This is our result. So when x is approaching to 4, the result in y is 8. So we have already the limit, but if we want to like know here of what's going on, why we have 8, we could also have the equation. The equation is limit when x is approaching to 4, x 2 minus 16 divided by x minus 4. So we can't substitute the values, because if we substitute the values we could have 0 divided by 0, and this is indeterminate, so this is trash. So we have the we need to do the approximate. So with 3.9 and with 4.1. So we need to substitute these values in the x's. So having this, we could have that 3.9 minus a square minus 16 divided by 3.9 minus 4. We have the result of 0.79 minus, and in the back minus 0.1 with a result of 7.9. And in the other hand, substituting by 4.1, we have the value of then it's almost the same, but we have to do it. So here we have 0.81 positive divided by 0.1 positive, so we have 8.1. So if these two we add and divide it by 2, our result is 8. So we there have our limit.